This is a diagram of how they forecast your schedule. Go ahead. And, the students actually fill out their little schedule, and that's this guy right here, right? And those schedule requests are routed to various departments. No, I'm just kidding. What is this? This is to understand this, what you have to do is understand that this, look at these guys and look at the things going to it. So this is transportation, and almost all of our transportation is fueled by what?
Petroleum.
Petroleum, there we go, imports. And this is how much we import, and this is just U.S. petroleum, right? Now, if you look at this, there's just a few tiny, tiny things, like 0.02% of our transportation is powered by other sources, right? And this is like, I don't even know what that is, right? I mean, it's like some alternative thing. This would be like biofuel, right? That's how much of it, at least in, when is this, 2002, right? Okay. And then you can go in here. Petroleum is also used for non-fuel things. So this is like plastic. There's also, certain medicines and things like that. Basically, anytime you need long-chain polymers, you use petroleum for that, right? And then this is industrial. Industrial uses kind of a diverse kind of a mix. So basically, our transportation is petroleum for reasons we'll talk about in a sec. But industrial, they'll use natural gas, they'll use coal, they'll use petroleum, right? And then this is distributed electricity, which comes from all these different sources, right? Okay. And then residential, commercial. We use a lot of natural gas. We also use a lot of electricity in our houses, right? And then if you go to everything that gets turned into electric power, what do we use a lot of for our electric power?
Coal.
We use a lot of coal because we have a lot of coal, and all you need, basically, the electric power is generated by these big steam turbines, so you just need a big fire, right? My uncle, though, explained it to me that oftentimes it's a misconception that coal plants are burning the coal. Really what they're doing is these lights in your room, okay, these actually suck the darkness out of the room, right? And so the darkness actually goes into the wires, and then it goes way out into eastern Oregon where they extract the darkness from the wires. And so when you go by those plants out there, you see those big piles of darkness, right, outside the plant. They're actually taking that out of your house. That's the darkness from your house, right? They pile it up, they load it onto railroad cars, right? And they load it and they take it to like Wyoming, where they stuff that darkness back underground. Right? It's a very dangerous job. They dig these elaborate tunnels and all this stuff, right? And they say that it's coal mining, but what they're really doing is they're sticking the dark, because that's where, basically there's an unlimited ability of the underground to absorb darkness, right? Yeah?
What happens when you turn off the light and you want the darkness back?
Darkness is just naturally provided by the room, right? And so when the light is on, it's sucking the darkness out, which is why it looks light in your room. Okay? This is an advanced topic, and your parents may not agree with that, but there it is, right? Okay. Okay. Now, what else do we use for electric power?
Nuclear.
Yeah, there we go. And there's not so much, I don't know if you noticed this, but nuclear, all of our nuclear is used for electricity. Why do you suppose that is? Almost all of it, right? Because generally, we don't put it in our cars, right? We don't have nuclear power plants powering our cars. The only exception to this is a military, right? The military uses a fair amount of nuclear. I believe they've got nuclear-powered aircraft carriers, et cetera, et cetera. And the beauty of that is that if you've got a nuclear-powered aircraft carrier and somebody shuts off your oil supply, the aircraft carriers and things like that don't need to use oil don't, right? So this is a strategic advantage, right? I like all the lost energy, right? Useful energy, lost energy. And this is because of the inefficiencies of things. Yeah? Oh, why is that? Just because everything, like transportation, cars are massively not efficient. Right? All sorts of unburned gas. They waste a lot of heat.
They just not change it.
Huh?
They make a lot of money this way.
Oh, well, we'll talk about why they don't change this, right? But obviously we're trying to make transportation more efficient. Look how much electricity wastes. Yeah? That's because for electricity, the cost is upkeep of the equipment, and so that they tend to do is operate them at optimal things for maintaining the equipment, right? Coal is cheap. They just burn more coal. It's better to make a less efficient thing for them cost-wise, right, that'll last a long, long time than they just burn a little more coal, right? Yeah? So anyway, that's where we are right now. So let's go through. Here's the United States, and this is what we use, our energy sources, right? We're almost all oil, and that's because oil is very, very convenient, right? We've got a fair amount of nuclear. This is gas, by the way. I don't know if you can tell the difference in the colors. It's very hard to. That's nuclear, right? It was unclear which one was nuclear, right? Coal there, right? And then this guy is hydroelectric, and this is geothermal, wind, solar, wood, everything else, right? Why is which so small?
Why is hydroelectric so small? We have a lot of rivers.
We do, but it's there's people living on the land, right? It's like what did they do in China? They flooded they basically by making the 7 gorges. No, it's like the 7 Gorges Dam or something like that. They've actually changed the axis of rotation of the Earth by putting that much water on there by like 6 inches or some crazy thing, right? We're not going to feel that, but the people that had to move out of those areas, I think they felt that. Right. Okay, so this is oil. These are the oil pumps that you see like in Wyoming, and we used to see these in Pennsylvania, not so much now, right? Oil is just wonderful. It's easily transported. It's easy to use. This is an amazing thing, right? Imagine pushing my Prius 45 miles. Picture that. That'd be a lot of work, wouldn't it? It would take like 10 of you guys. We'd attach you to like a harness and off you'd walk, pulling my car, right? Okay. Imagine pulling it at 60 miles an hour, right? That'd be even harder, right? For 45 miles, that'd be like tremendous, right? That's what a gallon of gas does. That's an amazing thing. This much gasoline. I put that in my car. I pay $3.89 for it or something crazy like that, or $3.79 or who knows, right? Okay. I put it in my car, and 45 miles later, it's time to buy another one of these. That's pretty convenient, isn't it? Yeah, this is why we use gasoline. It's like there's nothing else. There's nothing else for it, right? There we go, right? Okay. This is an amazingly efficient thing. But there's only so much of it. Right, so when they say fossil fuel, we just mean it's not being renewed. It's just we're using up what's there, and when it's gone, it's gone. We are now discovering petroleum more slowly than we're using it. Yeah, we've always before, I think like 4 or 5 years ago, discovered petroleum faster than we used it. We're now discovering it more slowly than we use it. Right, so we're gonna run out. It's just a matter of how much time, right? And then, people always say, it's always like, because see, like this is made of petroleum, yeah? This container is made of petroleum, the plastic, yeah, right? So when we run out, is it like no more plastic? Or are there actually there's a ton, there's a bunch of oil in like oil sands and oil shales that we're not going to recover, which isn't feasible to recover at today's price per gallon of gasoline, right? So we're probably not going to run out of petroleum, as in like we can't make plastic, right? Because but we're probably going to quit burning it in our cars. I'm thinking, when it's equivalent of $80 a gallon or something like that. I was like, I think I'll walk, right? Non-renewable, blah blah blah. I think we all know this, right? Natural gas is methane, plus there's other heavier hydrocarbons. There's other purities, but mostly it's methane, and it comes from dinosaur farts. Right? Or rotting vegetation is where it comes from. That's where it comes from, really. Yeah? Okay. But it is, your body actually makes methane when they make landfills and stuff rots in there, right? That makes methane. Methane is a powerful greenhouse gas. So one of the things that landfills need to do is they actually need to recover the methane and burn it and make carbon dioxide, which is less of a greenhouse gas than methane, right? So it's actually disastrous for environmental or global warming to release the methane into the air. It's better to actually burn it, right? Which just seems like a controversy. The problem with natural gas is it's very hard to transport, right? Oil, we just put it in great big tankers and ship it off, and oil will just be there. We can put it in an open container and nothing really bad happens to it. But natural gas, not so much. We have to have these high pressure containers. We can liquefy it, right? Liquefied natural gas, and this is that whole controversy of liquefying it and then piping it through Oregon. And do you want to live by a natural gas high pressure pipeline? Do you? Did you guys read there was like some neighborhood in California